and what their current status is. And I'm just going to go quickly through these. On the coverage side, which is the first line here, 1.1 coverage, you want to have over coverage everywhere all the time with a minimum elevation angle of no less than 10 degrees. We can do that on the ground if we use 10 gateway locations. This used to be 8. I had to increase it to 10 due to the 10-degree elevation angle constraint. So we now have 2 more. And I moved one from Mauritius to South Africa and then added one more in the Pacific region to plug the hole. I'll show you in a minute what that looks like on the map. But so that's the first change, 10 gateways rather than 8.
What was the reason for the change from Mauritius to South Africa?
I didn't have the constraint of the minimum elevation angle in there before, so without that, it was fine with 8. After I put that in, we had a hole in the South Pacific. So then I moved Mauritius to South Africa and then put another one in between on Western Australia, I think. I'll show you in a minute.
Okay.
I guess
Ralph,
I can just pull it up right now. Go ahead.
Question for you. So these are the Akash teleport gateways, obviously. Requirements list. Do we need to call out the fact that every country will have this so-called client gateway that is 1.5 meters?
Yeah, I mean, that's a different topic. So that's, for instance, if we wanted to do airplane connectivity service anywhere on the globe, we will need those 10 gateway locations, independent of the clients on the ground, right?
Understood that. And if we only want to provide service to Africa, then we only need, for example, South Europe and South Africa. Is that right?
Yeah, that's correct. Actually, I just noticed a mistake on the chart. The one in South Africa should be purple. Let me just check that really quick. The 3 purple ones are the ones where we're starting at to get our initial desired coverage for Africa and the U.S. Europe flight routes.
And the Alaska gateway that is just for the mobility Honeywell market. Is that right?
Correct. Yeah. Or if you wanted to have coverage on the ground in the San Francisco area.
Okay. And okay. So I understand.
So the one I added is in Bangalore, India, because we had a hole in the middle, and I moved the one from Mauritius to South Africa, and then I think there is one more in Perth, which I actually forgot to show. This one is in the wrong place. Hang on. I keep finding mistakes in my terminal. There is one here, which is, that one is the only one that's not owned by KSAT. KSAT doesn't have anything in Western Australia, but I did find an existing teleport. They're owned by NewSat Networks, which host other people. So that's what they do.
SSC has one as well. I think O3B has a ground station in Western Australia, kind of in the Dongara, Perth area.
Yeah, it's pretty common. There's a lot of radio astronomy and ground stations on the western side of Australia because it's very dry air, so it's great for connectivity.
I have a question for Jeanette and Ralph. These 5-meter dishes that we're planning for these 10 gateways, these are so significant that and our usage is so continuous that we wouldn't be able to outsource this to KSAT. Is that right?
When you say this, what do you mean this?
The dishes, the 5-meter dishes, that the fact that we're going to be using them, nonstop, continuously, and it's like, around the clock, and also.
So you're saying the operations, not like the buying and the setup and everything.
Actually, I am asking about the buying and the setup. So.
I think they would. That's part of their services.
No, okay. So my question is about the CapEx. Do they actually have their own 5-meter dishes?
No, these would be ours.
Okay.
Because of the frequency, because we would be using them. We're not sharing it like they have with the Earth observation folks that are basically sharing ground stations, because we would need it when we need it, as we need it. They would be dedicated dishes to us.
Okay.
And Felix, there are some options there. It is true, we'll be using them all the time. However, when I spoke to SSC previously, and actually I think KSAT as well, or at least Sigtel, SSC, and someone else, like a state provider, I forgot now. But essentially, it's not uncommon for them to buy the dishes for you, and then you lease them from them. They actually like this as a business model because they can just amortize the cost of the antennas, and if they get a guaranteed user, which pays the rent. So if you wanted to backload the financial profile, you can say, okay, you guys buy it, and we sign a contract for the lease of those capabilities over the X number of years.
Yeah, I think we might do. I remember, now that you say that, I do remember both of them saying that was, Jeanette, if you remember the very earliest conversations we had with them, they said that as long as we give them the commitment, the long-term contractual commitment to use the bandwidth, that they don't have a problem leaning in and spending their own money to buy and install these dishes. So that I think would be...
What I'm going to ask is who ends up paying. So we would end up paying more ultimately in the leases, probably, than if we bought it out ourselves.
That is yes. I mean, just like when you buy a house, interest rate, yeah, so definitely. But of course, that is in favor of preserving cash up front. We don't have to raise, so much money for all of this. That's $10 million per site. Three antennas per site. So yeah.
Yeah, that's one way to go. And you're right. What they do essentially is they take out a loan secured by their existing customer commitment, which is you guys. They then pay for the equipment and have it installed, and then you pay them rent or lease for their use as you go, and then they amortize the cost and make some profit after 2 or 3 years.
Yeah. No, my recollection was that KSAT sounded more flexible. SSC sounded a little bit less, but they said they were open to it. I think it always comes down to the details of the contract, of the commitment.
They're also watching KSAT eat their lunch, so
that's true.
The other thing to share that with this group related to the ground stations that Felix and I talked about the other day, this is jumping back to the smaller in-country gateways, is that KSAT is also, I checked with Catherine, KSAT can also, if we do want to do like a massive kind of contract with them and have them do a lot of the work for us, they can actually set up the in-country gateways, even if it's not their teleport and might be a teleport owned by Orange. That's a service that they offer too.
Okay. So, Jana, this is what you shared with me before, that
yes,
they would be willing to essentially. So Nara, heads up about that. KSAT is offering to OpEx manage, help us manage the in-country client gateway that we would co-locate on site with Orange. So that's a very important feature.
Yeah, with their experience and credibility, that's going to lend. It's very positive. I like that.
Absolutely.
The only question I have, if I may ask, regarding phase 1, would there be coverage at all to parts of South Asia and Pacific?
I'm sure that everybody always wants money. Everybody wants business. I don't think they will say no for giving them a new market.
Mm-hmm.
So I can't speak for them, but I'm sure they could be enticed into it. Sorry, go ahead, Jeanette.
No, Nara, is your question that with these 3 site locations in purple, can we serve Asia Pacific?
Yes, that's correct.
Okay. That's maybe a Ralph question.
Yeah, you don't get quite that far. You'll get some, right? So it overlaps a little bit to Bangalore side, but that's about as far as you get in terms of longitude. If you wanted coverage in Asia Pacific, you would have to pop up either Tokyo or Western Australia.
Yeah, I remember a couple weeks ago we talked a little bit about that footprint. Okay, yes, it was. If there's any way for us to think on that one.
Actually, a statement, Ralph, you made earlier made me believe that Asia would not be a problem. I think you said you were, so in situating these 10 gateways, I presumed, maybe I misheard, that you were trying to make sure that coverage is complete and continuous.
Right.
Are you saying that that's not quite right with Southeast Asia, the Pacific Islands?
No, if you do all 10, you've got global coverage everywhere.
Okay, okay.
But we're talking about the first 3 rollouts. So for phase 1.
I see. Yeah, so for phase 1, so right now we don't have a pending phase 1 customer. The minute we have a phase 1 customer, then of course we turn on that gateway, because that will be paid for by the customer. So I just didn't include it in phase 1 because we just have Orange and Honeywell right now. We don't yet have.
Nara, for the purposes of your slide, for your slides that you present to APAC customers, we can maybe turn it pink or make another color, like this becomes
just
pink
for the sake of
when you sign.
Yes. It's just that Central Asia and South Asia is such a big market. I mean, you're talking probably a couple billion people. Indonesia itself is a very important one. Philippines, Central Asia, like Pakistan and Afghanistan and stuff. Okay, as long as we could, even for presentation purposes, that would help a lot.
All right, so that's it on the number of gateway story. Let's go back to our requirements list. Okay, next up is coverage for aviation. So Honeywell wanted us to cover everything, including the poles. They do not currently have polar coverage, using either Inmarsat or ChinaSat for the Chinese market. They are looking potentially at using new constellations to get the polar coverage, but right now they don't have it. What we can do is, with that limitation of a 20-degree elevation angle, we can do about 99% to 60 degrees latitude, and then above that, we will get coverage about 85% of the time. So that's the best we can do with the current constellation setup. If we wanted to get beyond that, we would have to add another satellite ring at a higher inclination.
So let me understand. And when you say another satellite ring, you mean like 2 more satellites, basically?
Yeah, essentially. And we pull up the relevant pictures, so we're looking at in-flight connectivity stuff. It's the global aviation thing. So what's hurting us is the 20-degree minimum elevation angle requirement, which means we can't go as low to the horizon. And because of that, we have this sort of bald spot at the very high elevations. We get 100% up to 80 degrees latitude, and just that last 10 degrees is where we have some issues, where we have outages every once in a while. And it's pretty good. I mean, you can see the percentage in terms of time, depending on where you are. But depending on what taking the airplane across over the pole, right? So they might be right in one of these places and then get that 10-minute outage or something like that.
Okay. I have a question for you. Two questions. Number one question, and I just want to put this to bed because we discussed it briefly last time. Are you confirming then that no amount of pitching can help us close the pockets here?
Yeah, confirmed. This is due to the Earth being in the way.
Darn Earth. All right. Second question then is, can we take from elsewhere, such as, because we don't have any as yet early adoption customers in the Southern Hemisphere, but I don't want to. Then we lose some coverage there significantly. I was going to say.
Something you said just triggered a thought. I did not consider this. Coverage will be better at altitude. Because if we're high above the ground, the Earth is not in the way just as much. So this coverage I'm showing in this chart right here is actually on the ground. I might have to do this one more time and check what it looks like at 10,000 feet or even at 50,000 feet. It might be significantly better. So yeah, thanks for asking the question. I didn't think about this. Because I remember we had the same challenge in policy. We had full coverage everywhere from like 100 kilometers and up, but we started getting polar outages as you go lower in altitude. So I'll check on this. It may actually be better.
So this graph here is actually at the ground?
Yeah, it's ground level.
So
the default is at ground level.
The first bullet there that you have, so is not right then.
Yeah, you're correct. That's where we need it. But the analysis assumed ground level, so I'll have to check on that. That might be better.
Okay, all right.
We'll revisit that one once I have an answer. It shouldn't take too long. And going back to this guy.
Okay. And then, but back to the in-country gateway. So are we basically going to take one of the user beams? So let's say we were at 4 user beams like we were before. Let's say we're at 4 user beams per beam, per satellite. And we want all 4 user beams going to, let's say, Côte d'Ivoire. Would we then take one beam and assign it to the client gateway? Is that the way that would work?
That's the plan, yes.
Okay. I understand.
Okay, so coverage requirement number 3. This is on the ground for initial coverage in special regions that we have interest in. That was Central Pacific, Africa, and elevation angles as low as 10 degrees, and that we are okay as long as we have our 3 ground stations, and that's Fairbanks, South Africa, and southern Spain. And then the last one, this one is the orange requirement. This is concurrently covering 18 countries or 18 separate locations over a 10 million square kilometer area within a region of 7 degrees of longitude, actually. I keep finding mistakes there. But here's the relevant picture. Yeah, it should be longitude, not latitude.
Actually, I believe it is 17 countries, not 18.
Yeah, I just rounded up in case that, you want to have one extra. But yeah, I changed the list, so there's now 17 countries. I updated the map. I actually edited out the countries they told us they don't care about anymore. And it adds up to 17 countries and a total of roughly 8.9 million square kilometers. So I made the requirement 18 locations or 10 million square kilometers. I'm just rounding it up. And yeah, this should be 7 degrees off.
But I thought Equatorial Guinea was removed.
There is a Guinea and an Equatorial Guinea. They're actually 2 different countries.
I see.
I had written down Equatorial Guinea was the one to be removed.
Right.
Okay. Maybe I moved the wrong one then. All right.
So the countries I wrote down was Equatorial, Mauritius, Iraq, and Niger.
Got it. All right. I will put Guinea back in and remove Equatorial Guinea instead. So right now, in terms of meeting that requirement, what kind of view is that? In terms of meeting that requirement, we are not there. And that was because of, based on the old payload design, we don't have enough beams or footprint. If you assume 4 beams per satellite, we have an average of 2 satellites over that region at a given time. We only cover about 4.5 million square kilometers or 8 independent locations. So you can see it's about half what we need to do. So that means either we would have to have double the number of satellites or double the number of beams on a given satellite. So we're probably looking at 8 to 10 beams per satellite rather than just 4 in order to meet this requirement.
Okay, and if it's so one thing we could also add to that, I would like to leave some headroom, some powder, dry powder for covering the other half of Africa with another carrier, if you know, because that is a very real possibility that. MTN, I'm going to reach out to one of their senior executives. Now, we may or may not. I don't want to extend the scope of our MVP. This is an MVP, but my hunch is that the cost of a payload that has 8 beams versus a payload that has, 16 beams is probably not much.
Well, it's about the capacity. So if each satellite has 8 gig of capacity, and we're promising Orange 24 gig dedicated to them, then we need a full 3 satellites dedicated to Orange. And there's not. So it's not. I think it's not necessarily a beam question as much as it is a capacity question.
Sure. So setting aside the beam then, on the capacity side, it's very, very likely that Orange will not eat all of the 24. They're already talking about, hundreds of megs for a country. So it's possible that they will back out of taking all 24. They'll want to take less, in which case we have extra gig to sell, and but we will not be able to sell the extra gig if we don't have beams to provide the capacity. So that's why I'm bringing it up now. As you, Ralph, designed the payload, if we could do more beams is better. That way we can maybe add another 1 or 2 customers to take up the full 24 gig. Based on the last call, it sounded like they're already kind of, suggesting that, cell towers, countries may not use up to 1 gig,
Yeah, there's a step switch. If you remember the last event cycle, right, we were looking at the 4 Navision antennas versus an array of some kind. Once we make that step switch, the number of beams is very flexible because we can subdivide the array in which way we like.
Okay.
So I think we have some flexibility there.
Very good.
Okay, so that's the story with concurrent coverage. So that's coverage. I think, it's not perfect yet. It's not all green. Obviously, we want it to be all green eventually, but we're close, and I think we'll get there by making the necessary tweaks. The rest of the story that I wanted to talk about today is terminals. So the terminal capabilities have a huge impact on what the payload needs to be able to do. I think it actually makes more sense to lock in the terminals first and then go and try to design the payload rather than the other way around. That was also one of the things that I took away from the conversation with Larry, to pay attention to terminals before we start to design our space segment. So we have 4 terminals in total, or 4 terminal types, which is the mobile terminal, the trunk terminal, the VSAT terminal, and the gateway terminal. And I will go through each of these one at a time. And I'm actually going to leave this chart right here and go into detailed charts for each.
I like that strategy, by the way, because I do believe that the ground terminal should be super ultra cheap. That way, we can bound the total cost of the constellation, because that's a real sneaky sleeper runaway cost thing, that ground guide. And I think that is an edge, an advantage that we have. Customers seem to like that we don't need an uber amazing terminal to get the signal. Because I'm really afraid of these I'm afraid of what other companies are doing with even Kuiper has talked about millions of grounds terminals, and I just don't understand. I mean, it's scary, crazy.
Yeah. No, it's a good point. Terminals are important. They drive a lot of the design decisions, and it would be good to have a good baseline. So I'm trying to essentially identify specific hardware for each of the terminals that we need. The first one is the mobile terminal. This is Honeywell, and they have the Honeywell JetBrains system, which you guys all know about now. There's two variants, which is the phased array that goes in the fuselage and the dish, which goes in a tail. And it turns out MCS, which is the bottom number, stands for multi-carrier system. So they all support multi-carrier, which is good. They do not support dual polarization. And Honeywell has talked about dual pol in the future, but I'm actually starting to learn that selectable polarization is common. Simultaneous dual polarization is very much not common for all the terminals. So I think actually we should stay away from dual pol if we can for user-facing terminals in general.
And why is that? I don't quite get why not use dual pol carriers for the ground? For the user?
I don't know. Nobody does it. So it is really technically challenging or expensive. I don't know. But I have not seen any ground terminals yet that support concurrent dual polarization.
Whitney, do you have any insight there?
I'm trying to think. I think we had 2 PAs.
On the gateway side of OneWeb?
Yeah.
Yeah, there were 2 PAs. But that was, I think, also part of the handover.
No, I don't think so. I think it was 1 per pole. I'd have to pull up the old notebook. You're talking about the gateway side, right?
Right. Yeah, it's more common for satellite gateways, so like the Akash gateway, or actually, honestly, we're planning the same thing. And there it seems pretty common. What I don't see any implement is for users, so user terminals. And I think maybe that's the reason that you essentially need 2 RF cables behind the antenna, which doubles the number of electronic components in the PAs and all that, and it makes it more expensive.
So I'd have to look back at my notes. I'm trying to jog my memory, but the OneWeb user terminals were like RHC, were right hand on receive and left hand on transmit. I don't think they had twice the number of PAs.
Selectable works, so you can switch from one to the other. I just haven't seen anything that does both at the same time. In terms of like dual pol for one direction, I guess, to be specific.
Yeah. I know there were plans to have them be dual pol, full duplex, dual pol, but I don't remember. I'd have to look at my notes.
Whitney,
if you have anything, that'd be helpful.
Whitney, do you recall what type of ground user terminal for the client side that OneWeb was focusing on? Is it always had been two terminals configuration, or were they looking at some sort of flat panel or hemispheric dome?
Yeah, both. I mean, the baseline was a dual polarization Intellion. They're in South Korea. Mm-hmm. And then we wanted flat panels, but I mean, we talked to everybody that makes flat panels, everyone, and they weren't really at a cost target that we could afford. Rockwell Collins was providing us with aviation support for phased arrays and designing a phased array solution. Kymeta we talked to for years, but they were never at a price point that would work. They were always above $1,000 with no plan, even if you set up a dedicated line, to being able to bring the price point below $1,000. Let me look through my stuff real quick, and I'll chime in if I find it. But the question is on both the gateway and the user side, if they had dual pole amplifiers.
Yeah, essentially if they're user
It's not the amplifier.
So so
the OMT is what induces the polarization, right?
I think that's correct, but as I understand it, need separate amplifiers for separate polarizations if you want to run them currently.
I don't know. It's a good question. Let me look at my architecture stuff, and I'll get back to you on that.
Yeah, no stress. I mean, this is what Honeywell gave us, and I think it would be better for us to support the existing installed fleet rather than design for future upgrade. Because
I'm fine with that. With respect to the Aero mobile terminal assumption, yes, I think I agree with you about supporting. I mean, I guess there is some probability that their future. He did say that the future install may support that, but at the moment, this is all they do. It does, limit. I guess so. If we build in the dual polarization capability for the ground, will Honeywell get it for free? Or maybe you're already answering that question, that you're not heading in that direction.
Yeah, I don't think we need it. It doesn't hurt us that much, and we'll talk about the spectrum plan a little bit later. I think we're fine without dual on the other side, and everybody does multi-carrier, and I think that's the better way to go.
Okay, that's fine.
So this is the aircraft side. This one is really, I would say, not contentious because we have the customer told us this is what they want, so that's what we'll have to support. The two caveats here is, I think the antenna performance will remain the same, so we can use the specs we have for this in our link budget. The current modem does not go beyond 100 megabits per second. So they will have to improve that to be able to actually process the capability of up to gigabits per second, take advantage of it. So they might have to upgrade the in-cabin electronics to do that. But I think that's a less painful thing to do than changing antennas. So they'll probably be okay with that.
Ralph, just so I understand what this is 100 watts of power that will be shooting up from the tail of the aircraft to our satellite.
Correct.
So
it's a 300 watt radio, so it sucks up 300 watts of the airplane and then spits out 100 in our.
Okay.
But yeah, this one was fairly well defined. So that's the current baseline I would then say we should use in our link budget calculation, so we can both include the flat panel and the little dish. One is spent for business jets, the other one for larger commercial jets. And then moving on to the second one, this is the VSAT terminal. And you guys saw this in the Orange presentation yesterday. So we've moved from the 1 meter to 1.5 meter because that's the only one I was able to find. I was not able to find a 1 meter terminal that meets our frequency bands and tracking capability and is existing in the market right now. This one was actually designed for MEO constellation and LEO constellation. So they're aiming this terminal at O3b and Telesat and all the new LEO guys. That's why they put it together. So it's very well suited for what we're trying to do. It is Ka-band capable, and it's out there. So it gave me a good point to get actual physical capability specs that we could use in our big budget. So I propose that we use this as our standard VSAT terminal in the design calculations.
You said you were not able to find a 1 meter equivalent of this guy. Is that right?
Correct. Yeah, I could not find a tracking 1 meter, say, A-band system. I think there just hasn't been any use for it so far. And I remember this from Odyssey as well. We had a hell of a time trying to find the K-band tracking antenna for our demo satellite, and bought a custom one because of that.
Yeah, I think 1.2 is more traditional than 1, just from broadcasting heritage.
There's probably some reason why everyone coalesced around 1.5. And this 75K price, this is are there cheaper versions, like a one that's like half the price, or is this already considered a bargain?
The 75K number is an estimate that I put together based on the cost of a comparable system. I couldn't get a quote for this thing yet. I haven't reached out to them. But there is a existing system, just a single antenna version for marine applications that goes for 45K. And I found that just on the website. You just buy it by clicking on it, put it on your boat. And that was 45K. So I figured, okay, 2 antennas is probably about double, but not quite. 75 seems like the right number. But that said, if we agree that we want to use it as our baseline, it might be a good idea for Jeanette to reach out and actually get a quote for these things.
Yeah, please do reach out. Using it as our baseline, I like the idea very much. Just having a one-size-fits-all for all of our needs at the client side, both users, user terminal, I should say the cell tower, co-location, and the client gateway. They might even find out if there is a discount for buying a lot, like, triple-digit quantities of antennas. There might be a meaningful discount there. And we would have to buy 2 for every client gateway site. Is that right?
It's what's in the diagram. So that's a complete terminal with the 2 antennas and the ACUs, as we call them, which steers the antenna, and then you get a single modem. But that's the whole package, which allows you to have a continuous link without any breakage on handover.
I don't understand. Are you saying that there are 2 already built in?
So you see the diagram in the top left corner, top right corner, I'm sorry. It's 2 antennas, 2 antenna steering units, and then a single modem unit, which can handle traffic from both of them. It's switchable between the 2. So this is what Intellian sells as a complete package that allows you to have uninterrupted connectivity on a site.
Excellent. And that's 75K for the 2.
Based on my estimate, yeah. We'll see what they come back with.
Very nice. Okay, yeah, let's see what kind of official price we get. This is good.
Yeah, I don't know. Jeanette, do you want to run that down if you have time for it?
Yeah, I can get in touch with them. I think I've got an old business card from Intellian.
I have their contact info if you need. I know.
Yeah, if anybody has relation to that, I don't know them. But
yeah,
I know
their CEO, CTO, their salespeople. I've been over to Intellian multiple times in South Korea.
I figured somebody has.
Yeah.
Nice.
Okay, the other option, and I don't know if we want to use it in our design work because I don't know anything about it, is the steered flat panel. These are getting more and more popular. A lot of people are working on them. I don't know how real they are. But this was one I found, which was built by GetSat. That's an Israeli company. And it was built for O3b mPOWER. Looks very interesting. It would have to be a little bit bigger than what they designed it to get to a gigabit, I'm guessing. But it's a single panel for both transmit and receive, and it has super fast mechanical steering because it's a flat device. It's easy to do that. And if you can do that, you would only need a single one rather than 2 because it switches direction so quickly that you won't notice the outage. So that's potentially attractive. But again, I don't know enough about it. So if you wanted to use that in our design work, we should reach out to these guys too and see what they have.
I have a question, kind of an education, as Jeanette often says, back of the classroom question. These antennas that are moving all the time, that mechanical motion, I got to believe, one of the first things I learned in Mechie 101 was, there's wear and tear that happens with that. And the lifetime of a moving thing or a moving joint is going to be shorter than when nothing is moving at all. How long do these things last before you have to replace them? Just out of curiosity.
I don't know. I know the big guys you have to service on a regular basis. Like a big moving antenna, you actually have to service the gears at least once a year just to keep them running smoothly. On those little guys, I don't know. You'll have to ask the manufacturer.
Okay. And then what type of data rate is the Intellian guy going to support this 1.5 meter?
I didn't find a number. It's built for O3b mPOWER, so it should be up to the task in terms of a gigabit per second, but yeah, we'll have to ask them.
Okay, probably more than a gig, for sure. Okay.
So if everybody's okay with that, then I'd say let's make the 1.5 our current design baseline, since we have good information for it, and then as we learn more, if at some point we wanted to assess the flat panel tracking option, we can do that if we get better information about it.
Ralph, quick question. Does the application for this equipment here would be mostly for the cell tower?
Yeah, so this is the VSAT terminal, very small aperture terminal, and this is primarily meant for cell sites, or it could be both, or it could be a gateway, a user gateway, if they don't want multiple gigabits of throughput, right? My guess is the Intellian system might get you to maybe 1 gigabit per second, but probably not much more than that. So if that's enough for a regional service provider gateway, then they could use it for that as well.
Thank you.
Okay, everybody on board with the VSAT? Okay, so next one we have number...
This is great.
We got number 3 or 4. This is the trunk terminal. So this is a terminal that's deployed for IP trunking. If you want absolute maximum throughput, let's say you want to connect an office part to a drilling platform, this is still for the customer. This one, again, was developed for O3b. This is a Viasat Neolink IP trunking terminal, and it's got good size and very solid capabilities. I think that would be a good match for using that as our baseline. And again, these come in an installation with 2 antennas. So you get the 2 antennas, and then they have the control unit for each antenna, and then the RF chain behind it to get to the demount part. So this is how they usually sold in packages like this. There's one notable difference from this one to the previous one, which is the VSAT guys. This one you can install on just about anything. This one, with its size, you have to pour concrete and have a foundation, as you can see in this picture here. And that's the biggest difference in terms of cost, actually, the preparation of the site.
Ralph, the reason for going to 4.5 is because of obviously the capacity that is intended. And what is that capacity number? What is that data rate?
We're going back in our use case for the trunking. I think
it's like 3 or 4 gig, maybe.
It is. We're doing 2 gigabits per second. Minimum.
Okay, so if it's 2 gig, then do we really need the 4.5? I think the 1.5 will do, probably.
I don't know. We'll have to run the numbers, right? But that's the thing. If we can get to 1 gig on the 1.5, can we get to double that on the 4.5? Probably. And it was an existing actual terminal hardware that you can buy. I don't know if there's such a thing as a 3 meter. And what the capability would be. So again, I think I wanted to pick an existing actual set of hardware to do the design work, and then at the end of the iteration, if the answer is, you know what, with that 4.5, if you're getting 6 gigabits per second, that's something that happens, very good. Maybe it's overkill, and then we can do another iteration and try to find a more customized solution. But for now, I think it will give us better confidence in our design to say, this thing is real, it's a piece of hardware, we got the specs for it, and we know what it can do.
Yeah, I mean, I think unfortunately we don't know what level of how much customer will need us to trunk. That's the bit of the challenge here. So maybe what you could do is run the numbers for both a 4.5 as well as a 1.5 and see, that way we can tell the customer with confidence, if you're trunking this much, the price is this. If you're trunking that much, the price is that.
Absolutely. I mean, remember, this is identifying the hardware, not the application. So if you wanted to use a VSAT terminal, which is this guy, as a trunking gateway, you could. Absolutely a choice. But if you wanted, full bore, all you can get, then this is the one you should choose. So it's up to the customer to choose which one is the right answer for them.
I got you.
Ralph, what do you think the maximum throughput would be for the 4.5 versus the 7.3?
I don't know. So we got to work that, right? That's the next step. So if everybody agrees that these are the 4 terminals we're going to go forward with, then I can solicit Brittany's help to put them in the link budget. Because we had a variety of terminals in there already. Now we can actually update those with this very specific set. Say, okay, we've got mobility, the aircraft terminal, the JetWave. We've got the VSAT. We've got the trunk terminal. Here's the actual specifications for them. Put them in the link budget. Design our satellite payload the best we can and see what the resulting performance is.
And for the 1.5, where do you think the max output would be?
I'm not going to even guess because you never know. We got to do the numbers.
You were saying earlier you were thinking if a customer needs up to 1 gig, the 1.5 would suffice. Yeah,
I mean that's the target, right? So we have targets for all of these guys, and I've chosen them because I think they will meet those targets. What they will actually do in the end, as I said, we got to do the analysis.
Okay, just the thought is that the 1.5 for cell site backhaul at 1 gig is quite a bit, which is more than enough for probably the next 3 years for most developing countries, even the Orange operations. So at least we have that to work with.
Right. And the good news is by doing this, you get very solid cost numbers. You'll know exactly how much they cost, and you can put it into your operations model, which is very useful.
Do we have anything smaller than 1.5, like we talked about, 0.8? Or is it?
I'm sorry, say that again?
Do you have a smaller option than the 1.5, like a 0.8 meter for cell site?
Not right now. So let's start with this, and again, if we find out that this is overkill, we can look for something more customized.
Well, I mean, one gig at a cell site is definitely going to be an overkill for most operators. That's why I'm raising this point now, and kind of if you can make a mental note, like I mean, with the Orange, a lot of their territories is they're asking. Remember, the max that they were asking for was 250 meg. And so the 1.5 meter dish would be a bit of an overkill. It would impact our cost factor to them. So we have a small option.
No, that's a lame statement because you don't have a confirmed price point yet. So we don't know what the cost model looks like, and we don't have a confirmed performance yet. So you're making conclusions without having done the work. Let's do the analysis first. Let's get the quote from the vendor.
No, I totally understand, but
put it on the ops model, and then you can decide whether it works or not.
You have
Don't tell me a foregone conclusion. That's bullshit.
Yeah. I mean, go back to the email from Sylvie and Philippe, right? They never went above 250. I'm just stating the fact. Go back to the email. They never went over 250 meg, and so they also talked about 0.8. I just want to throw that out there because I mean, if we come out, if the only option that we have is 1.5. They're not gonna buy it. They're not gonna buy it for cell site backhaul. I'm just saying. I'm
not saying our only option is going to be 1.5. I don't know the answer. right? If we run this system and we design our payload and we get the numbers, the answer may be that below 1.5 billion doesn't close, then yes, that is the only option.
Okay.
And that's what you're going to get.
Yeah, so
but we don't know if that's a problem.
Yeah.
So let's do the work and then decide if it's a problem.
Yeah. Let's proceed as you said, Ralph. Nara, what he was saying is that he's gonna. We actually haven't run the numbers yet with this dish, so we're gonna do that and see whether there's a lot of overage or if it's under or if it's just right. So this is a starting point. It may be that this is all we have because there are no, smaller dishes that can move. Because remember, it's not just the diameter that is the requirement. There's also the ability to track, and then there is, that's a big one, ability to track. And he couldn't find a 1 meter dish that is tracking. So this may be the smallest and cheapest out there. I will check with Larry because he mentioned smaller, but I don't know if he was also thinking of tracking. So I'm happy. Let's run with this one. Let's see what the numbers actually show. I will say that at this budget of $75K, it still works, Nara. In terms of having to support all these countries, it's still a decent price. I would like it to be lower, of course, but the numbers, it'll still work in terms of us supplying them with these antennas.
Yeah, no, it sounds good. I mean, the nature of the data throughput in the next 5 years, they can easily jump from 250 meg requirements for per cell site to up to 500 quite quickly. So having something at the initial part of as an overkill that doesn't is not a deal breaker by any means. So just something to think about.
Thanks, Sarah.
All right, so we're done with the trunky guy. Everybody okay with using that to design the payload for now?
Yes.
Cool. All right, the last one is our gateway. It's the last one of the entire set. So this is the gateway that comes with own operate. Again, I looked for something that exists in real life and for which you can actually get specifications. I know we looked at or considered previously getting a good deal on the existing equipment that might still be sitting at Intertronics. I know they're a good company. So look at what they have that makes sense. The challenge with the gateway terminals is the very high frequency that needs to support the V-band stuff. This is not common, and it requires extreme precision in the reflector and also in the steering mechanism. There's not a lot of companies out there that can do that without charging you about $1 bazillion for each. So Intertronics was a good choice that we settled on in the last exercise. So that's what I used as a baseline. This was a 7-meter 2-axis dual antenna. It may or may not be overkill, I don't know. But we increased the target throughput for the gateway link to 8 gigabits per second, which is quite a bit. So this seemed like a good place to start. This should be less than 2 million, certainly. And they will have the performance that we need to get this thing to close, I hope.
Is this the Stanford dish? How big is that dish?
The Stanford dish is massive. That's, I don't know, certainly over 10 or 12 meters. You can look at that though.
I guess we can't use it because we want total control, right? We want to use it all the time, so.
Well, the Stanford dish is a mesh dish, and the meshes only support very low frequencies.
I see.
That's part of the challenge. The high frequency stuff, you need a solid reflector, and it's got to be very precise. But just for reference, that's a 45-meter antenna. You only need 7.
Yeah, it's a little bit nutty.
You would never be able to move that thing fast enough either.
I've seen it move, and it moves. It's super slow.
Right. So this is 7 meter is a common size. I've seen a bunch of them when I was in Singapore, looking at sites at Singtel. A lot of providers use them, and I don't know how many out there in KA yet. There might be a couple because of the smaller size.
This would be V-band, right?
Yeah, you're right, V-band. There's not that many V-band. There's some in K-band.
Viasat does. Viasat has, I think, some work that they're doing in V-band. I think those are the folks that. I think I've talked to those folks. Trying to think who else. Like some of the bigger companies do V-band. Like there's like two dishes. It might be L3 and Viasat that I think are like the two biggest companies that make dishes.
Yeah, I had quotes from General Dynamics before too, but they were very expensive. And I think we may have gotten one from Viasat too, but at the time it wasn't off the shelf. So I said, yeah, we could do this, but we have to figure out how.
Yeah, it was L3 Daytron, actually, that we were talking to.
This is really massive.
Almost 2 years ago.
And the reason it takes 18 months to make, probably?
Well, the reason these look very sturdy, by the way, the photograph is the bigger one. The drawing is an extra 7 meter. The photograph, I think, is a 12 meter. The reason these take a while or they look pretty sturdy is because they need to be extremely precise in pointing. Because when you have a dish of the size, which is 7 meter, for a very high frequency, your beam is very narrow. So you have to point it very accurately. Otherwise, you get killed by steering losses. That's why they look beefy. The support structure is very stable and has to be very precise in terms of being able to point it.
So the higher the frequency, I thought the higher the frequency, the smaller the antenna.
Correct. For the same gain, higher frequency means smaller antenna. So, for example, looking at a 7 meter V-band dish is probably comparable to a 12 meter Ka-band dish.
I see.
And you might have mentioned this, and I'm sorry if I'm making you repeat yourself. What was the drive to 7 meter over like 5 meter?
So if you look at the use cases, we've been working on the number on the game terminal went up. It's now sitting at 8 gigabits per second. It's metric.
Okay. So it's the return going up?
It's actually symmetric because of the trunking use case.
Okay.
And, again, this is an iteration, right? So if we use these, I think we have solid information of actual hardware. So we have confidence that whatever the result is, it's real. If the result is that this is not something we want to pursue, then we iterate again and pick something different.
Okay.
So that's it. This is the full lineup. 5 terminals, ranging from 30 centimeters to 7 meters. Different minimum elevation angles, depending on whether it's an array, tail-mounted antenna or ground-mounted antenna, and then capabilities in terms of maximum power output and gain for receive and pointing error. So all of these are based on real-world physical hardware, and I would suggest that we use these to update the link budget and then use that new link budget to design the satellite payload.
Yeah, I think this is great. The extra 1.5 would ease the burden on the payload. But this is good. This is good.
And yeah, I don't know what the price difference is between a 1.5 and a 1 meter, right? So maybe when we talk to Intellian, we can ask them what could be a significant difference in cost if you made it one rather than 1.5.
Yeah.
What did you mean by when you say selectable for multi-port? What does that mean?
That means they can operate in either polarization, but you can't do both concurrently.
I see. So you're, I know in the beginning for the aviation, you said it was selectable, but for even the grounds, the VSATs, I missed that there. So Intellian is also going to be selectable, not concurrently.
Yeah, and I was surprised at that too. So they don't do a dual pole. The trunk terminal, Neolink terminal from ViSat have actually two statements, and one says that's selectable on the fly, but then another one actually stated that you have to specify when you order it, which is almost like you can only do one and then you're locked in. But I would expect most of them can select this on an ad hoc basis. You just can't do both at the same time.
So this effectively cuts our capacity in half. Like if we claim 8 gig, in reality, if we are limited to these particular terminals, then that's actually 4 gig.
I don't know if it hurts us that much. So if you remember the different options we looked at for the spectrum plan, only the very first one is dual pole. Everything else is single pole. So the really clever 4 individual carrier one that we got from NDA was single polarization. This is multi-carrier.
Because they're doing multi-carrier, okay.
Exactly, and everybody supports multi-carrier. That seems to be a more common thing.
Okay, so we still get a pretty significant, we still get the capacity that we want.
Hopefully. I mean, my recommendation would be to baseline the one middle, because the one Plan C on the right is only compatible with individual reflectors. And I suspect we're not going to get there with individual reflectors. But we can try both B and C. We would just essentially give up on A. And I don't know if A was a good choice.
So with your recommendation is B, and that would give us what type of capacity?
It gives us 800 megahertz per channel if we have a 4-beam system, or 3,200 megahertz in total. And then the actual throughput depends on how high we can push the coding scheme. This again depends on, can we close the link budget with the terminal sizes that we've selected. So we've got to plug that into the link budget and see what it says.
Okay. What would that mean for per satellite? That would add up to what?
I don't know yet. I can tell you that per satellite, we have 3,200 megahertz of bandwidth. I don't know what that translates into in terms of throughput yet.
Okay, you're going to run the numbers and let us know. Okay.
Yeah, next steps would be update the link budget with the terminals we've selected, see what the resulting capabilities are, and then we can trade essentially the size of the payload or the size of the satellite with the capacity you get. So it's going to be direct trade between, you want a 10 gigabit per second satellite, it's going to cost you, or it's going to be this size. You want a 20 gigabit per second satellite, it's going to be Y size. And then you can pick on that curve where we want to go.
Okay. I like the strategy of using what is feasible on the ground, and then work backwards from that.
Yeah, in a way, the satellite payload is a connector between two terminals. So selecting what those terminals are initially helps a lot with the realism on the requirements set for the satellite.
Yeah.
So that's all I have to share. So for next steps, I guess I'm just going to ask Ricky if she can help me with the link budget to get the info from those terminals in there.
I think Whitney stepped out, so I will send her a text message that you will be reaching out to her for LB analysis. Should I do that?
Yeah, I mean, I can do it too, but she knows it better than I do, so she'll probably be able to do it faster than I can.
Okay. All right, super. Well done. Good job.
Cool. I know this is a little bit, you kind of have to hand-wring a little bit because we're trying to make decisions, and it looks like we might be pruning potential path forward of the tree. But we're really not.
Yeah.
We just got to get to having a set that hangs together. And we got there in the first iteration, but not to the full level of fidelity that made it real. And hopefully this time we have a little higher level of realism, and then again we iterate until it's what we want.
All right, Ralph, what is the, how well do we serve South America with the gateway positionings?
It's global, so you get all of it once you have Alter.
Okay. Because we may get one or two early adopter customers there. So that's something that could come up shortly.
Yeah,
okay.
We actually have one right on the tip of South America. I forgot what the place is called, but there's one there.
Awesome.